Are you struggling with convoluting a three-dimensional array with a two-dimensional kernel? If so, you're in the right place. Today, we will explore how to efficiently perform this operation without getting bogged down in loops. I completely understand your frustration. Working with large matrices can be daunting, especially when you have 100 channels to deal with. You're definitely not alone in this challenge. Let's dive into the specific question at hand. One user asked, how can I convolve a three-dimensional array with a two-dimensional kernel for each channel separately without using a loop? This is a common scenario, especially when working with image data or multi-channel signals. So, what exactly is the issue here? When you have a three-dimensional array, it can be tricky to apply a convolution operation across multiple channels efficiently. Using loops can slow down your processing time significantly, especially with large datasets. Stay with me, because at the end of this video, I will share a powerful tip that can help you optimize your code even further. To perform a convolution on a three-dimensional array with a two-dimensional kernel for each channel separately, the user can utilize the function from the SciPy library. First, they need to import the necessary libraries. Next, the user should define their three-dimensional array and the two-dimensional kernel. In this case, the kernel size is 3 by 3. Now, the user can apply the convolution operation across all channels without using a loop. This can be achieved by using the convolve function with the mode parameter set to reflect. Finally, the user should check the shape of the result to ensure that the convolution has been applied correctly to each channel. Fun fact, did you know that convolutions are used in many areas of technology, from image processing to deep learning? It's a powerful tool that can transform data in amazing ways. Now, let's look at the answers provided by other users. An alternative approach suggested by a user is to treat your 3D array as an image and utilize OpenCV for convolution. First, reshape your array to have dimensions for height, width, and channels. Then, you can apply the filter2D function from OpenCV, which will convolve the kernel across each channel simultaneously. And here's the tip I promised. Always ensure your kernel is normalized. This can help maintain the integrity of your data during the convolution process. And there you have it. You can now convolve a three-dimensional array with a two-dimensional kernel efficiently. Remember, optimizing your code can save you time and resources. If you found this video helpful, please subscribe for more tips and tricks.